start the show. How you doing, buddy?
I'm doing good. How are you?
Pretty good. What are we going to do today?
Today we are going to work on undo and redo in our Sudoku solver.
That's right.
And we're also going to work on just a hint button so that it solves one square for you with the brute force.
Yeah, let's do the hint button first. I forgot about that. Let's do that. We'll do it on your machine. Is that cool?
Yeah.
And then we'll switch over to my machine to do the undo redo. Here's Campbell's machine right here. Okay, somewhere in the main window, .xaml.cs, the main one, right there.
Oh, wait.
Yeah, there you go. Either way works. We've got a call out here. We've got a try finally block that makes a call to solve the puzzle. Can you go find that?
Yes.
I think it's down near the bottom.
Try finally.
You can also, there it is, brute force attack. That's not the try finally, but that's the recursive method.
Yeah.
By the way, Campbell, can you go bring up your KidzCode page so everybody can see that? I'll bring it up on my machine as well. Here.
Wait,
on GitHub?
Oh, on GitHub. Yeah.
It's github.com/KidzCode1. There it is right there. I'm going to put that over in the chat room there so you can go see it.
And
then inside there you can click on Sudoku, and there's our latest code. So C# and WPF. What do you want to say, Campbell, about it? Anything?
Oh yeah, and last time we added a brute force attack, which is basically it guesses one number based on what can be there, and then it goes through the possibilities of every square. Basically.
Until it finds that it's blocked, and then it goes back and tries another guess.
Yeah.
And it sort of recursively does that. The problem with using the brute force attack is that it hits everything, and there are probably, I think, trillions of possibilities if we're starting out in a square.
Yeah,
so
and it definitely slows down.
It'll take some time, and we did not optimize it for speed.
No.
But it works well. Why don't you show them how it works? It works well if we have get to the one that we can't solve.
This is the one that we can't solve with just the solve button.
Yeah. So here we're hitting the solve button, and this is using our kind of custom mix of Sudoku strategies.
Oh, wait a minute. Oh, wrong one. This is the one that we can't solve yet. Yes, this one.
I think the clear is taking too long. At some point we get to a point where it stops. Is that it right there?
Yes. So right now I'm clicking and it can't do anything else. But if we hit brute force, here
Don't do it yet.
Oh, sorry.
Oh, you did it? Sorry. I didn't mean to interrupt you. Give me back to that state again.
Yeah. Okay, this is the state.
Right there. Okay. So at this point, I'm just gonna bring up my calculator. And I want to calculate how many combinations. And we can do this by taking the notes that we see in each of those fields and multiplying them by each other. I want to get a sense of
2.
Okay, good. 2 times
2 times 2.
Okay.
Times 2.
Okay.
Times 2.
Okay, I'm at 32.
Times 3.
Okay.
Times 3.
Okay.
Times 2.
Okay.
Times 2.
Okay.
Times 2.
Okay.
Times 3.
Okay.
Times 2.
Okay.
Times 3.
Okay.
Times 3.
Okay.
Times 2.
Okay.
Times 2.
Okay.
Times 2.
Okay, I'm at 500,000. I'm at 1,000,000.
Times 2.
Okay.
Times 2.
I'm at 2 million. I'm at 4 million.
Times 2.
Yeah. Now things get hard.
About 16 million.
Excuse me.
Combination.
Excuse me, kids. Okay, that's about 8 million total is what we got. So 8 million
Wait,
combinations. Just
I think you
these.
missed it times 2.
Okay, then 16 million.
Yeah.
Get a sense of what it is. So that's what it is. So go ahead and do the brute force. Now the brute force works pretty well though, because there's only 16 million combinations.
We're saying only like it's a small number, but it really isn't.
Everything's relative. This is the one thing you've learned. The more you understand about scale, everything's relative. So.
To just do brute force from here, I don't think I'm going to do it because it's going to definitely take a really long time.
You can try it. You can try it if you want. We can talk about something else.
I've just clicked it.
You clicked it? Okay. Yeah, so this is going to take a while.
The way that you can tell if it's kind of brute forcing is if you try to click on a square, it won't work. So right now I'm clicking on the square.
It's totally non-responsive. All of a sudden, once it's done, it'll kick in there. But yeah, at this point, it's a ridiculous amount, right? It's essentially, we were talking about maybe for each one of those, maybe 6 to the power of how many empty squares there are in there. Give me a rough estimate of the empty squares. What in each one we've got about 6?
8. Oh wait.
We've got about 6 empty squares on average. So 6 times 9 is about 54. So we're talking about 6 to the power of 54. Rough estimate here.
Oh, it's responsive, but I did the brute force and it only brought up the notes.
That's interesting. So it didn't finish.
Oh. Wait. Brute force? Yeah. What? This is really weird.
It's just done? Smells like a bug.
Oh, wait. Now it's now it's responsive again.
That's disappointing. Sounds like we got a bug. Also, look, there's a down in the bottom to the left of the 6 and the 2. There's an empty one. In the bottom right one, there are a couple empty pieces. Interesting. I'm not going to worry about that too much right now.
There's also
but
one here.
something to keep in mind. Creature Next is out there. Hey, Creature Next. Welcome.
There's also one right here, here,
Yeah,
here.
2 empty ones.
Here. No, 4.
Does the brute force not know how to fill in answers if it's just got one note? I'm not sure if that's the problem or not. I'm not sure.
I think we need to also
What if
put
I just hit solve for a second? Hit solve and see what happens. Yeah, it doesn't look good.
I'm just gonna control shift.
All right, so it looks like we might have a bug in there. I'm not gonna worry about it now. Campbell, we can look at that later and go after that. Instead, I want to talk to you today about, actually, we'll get to undo and redo, but first let's add that button. So see this code you're looking at right now, this button brute force click method on the screen?
Yeah.
Let's look at that. Tell me what this does.
This just, it creates a button. No, sorry, this doesn't create the button. The code in main window.xaml does.
Okay.
But this, it gives the code for the button, so it's once you click it, it basically does the brute force attack.
It calls this method starting at line 612. And what's the method do?
Well, the method, it calls brute force attack,
Yeah.
and it also, first it tries to do the brute force attack, and then after that is done, is that correct? Is that?
I'm not sure what you're looking at. What line of code you're on? Mystic Soda's out. This is Code Rush. Have you explained what an event is to Campbell?
Yeah, I think so. It's.
I think I have. But I haven't, now that you mention it, might not hurt to say it now. So an event is a way of having one class call something, notify another class when something's happened.
Yeah, so like the click of a button,
right?
The check of a checkbox,
anything. So say for example, we're watching an action movie, and I say, Campbell, if you see your mom drive up, tell me, because we got to turn off this action movie or we're going to get in trouble. And you're like, Dad, we live an honorable life, one of integrity. We don't do this kind of stuff. And I say, Campbell, just let me know if Mom comes.
So the event is
is your ability to tell me that you see Mom coming.
Wait.
And then you telling me.
Wouldn't it be when Mom comes?
Kind of. Mom comes, you see. But I'm not talking to Mom and saying, tell me. I'm talking to you. You're the class, I'm the class. We're both instances of a class. And I'm asking you, Campbell, to tell me when you see Mom coming. Because you're sitting in a position where you can see her on the couch. You can see out through the window. Does that make sense?
Yeah.
So the event is essentially your ability to tell me, and you trigger the event when you say, hey, Dad, here comes Mom. Right? Like that. We don't live a life like this. This doesn't really happen. But it's an example. Does that make sense, Campbell?
Yeah.
Okay. So that's what an event is. So the button has an event called onClick. If you do tab to next reference on this guy right here, you'll get right out to here and see this. This guy's an event. In fact, if we were to delete this for a second and just start typing in click, see, look at the icon. See that icon?
Yeah.
That's an event icon. Lightning bolt means something can happen. It's an event.
Okay.
Make sense? The wrench icon.
It means what is it called? Like an int or a bool.
Yeah, it's
or
a property.
Yes.
It's a property. Something we can change. So that's what's going on there. So that's an event. Thanks so much, Mystic Soda, for asking that. Also, Mystic Soda types in wrench for me, clearly noticing my brain needs some assistance this morning. I will take it. I will take all that assistance I can get. All right, so what does this method do? And you kind of were saying, well, is that right? But I'm not sure because I'm not sure what lines of code you're looking at.
I was looking at...
Whoops. I'm sorry, go ahead.
I was looking at finally, and I was thinking, do I have a correct understanding of what this does? So first it tries to do this code, and then once that is done, it does this code. Is that?
Yep.
Oh, okay.
No matter what, finally will always be executed.
Okay. Even if there's a return here.
Even if there's a return in the try block. Even if there's an exception thrown. Exceptions like go, whoa, let's get out of here until somebody catches us. We haven't really talked about that too much. Okay, so we've got a button that does a brute force solve. Now, one of the things that we're doing in this brute force attack is that we are, let me jump in here. When we're finding a value, we set has test value to true.
Yes.
If we have a conflict with it, we back it up and set it to false. We also, if we have any conflicts in a recursive call to brute force attack, if this fails, we're going to come down here and also set it to false. We're going to say, well, we're not going to do that one. Okay? So if it's true, that's one we filled in. So what I want to do is create a new button here. So add a new button called Give Me a Hint or something like that.
Okay.
What happens if you have a return and a try block and you have a finally block? Because I've actually never had that need. What happens if you have a return and a try block? You still get to the finally block. Is the answer to that question.
We want this pattern.
But what happens, like, okay, hold on. Maybe I don't understand the question, Mr. Soda.
We also want this.
Does return go first or last? I think the return goes first. You return the value, and then before it leaves, it goes in. So if you step through the code, you're going to execute the line of code that says return, value, whatever that is, and then you'll hit the finally block after that. That makes sense. So the return code executes, and I presume it puts that return value somewhere on the call stack or somewhere, so that when we get out of there, we pop that, we can get out of there to return, and that value is coming back to it. All right. Cool. You could just say new event handler right here.
Oh.
See that? And then you can tab to it. So
Okay.
cool. You got a hint? You can also double click on it to both get to it and do it. Okay. So here's what I want to do here. I want to I'm going to extract this method. Call it start brute force attack. Okay? All that does is just wraps around all of this, okay? And clears this piece. We take that out. So for hint, what we're going to do, we're going to start brute force attack. We're going to go through all our squares. We iterate through all our squares. You know what? Let's see. I bet I've got iteration code I can go find up here. You know the column and row stuff?
Yeah.
Kind of like this. I'll take that. Fine. I'm going to go through all my squares, but I'm going to start at 0, 0. Like that. And I'm going to have a Boolean that says found. 1 yet. And set it equal to false. All right. Then I'm going to check to say, hey, if, whoops, not there. If squares of row, comma, column. By the way, I can't stress how important it is when you start a project like this, Campbell, to say to yourself, whenever I access squares, it'll always be row first and column second.
Why?
Because what happens if I mix these up?
Oh.
Right? I just got a bug. If I do it the wrong way, if I know in advance I'm always going to do rows first, columns, or whatever, that sort of thing. So now what I want to do is check to see is, hey, does that have that trial? Wait, I thought it was like what test? What is it called? It's not test, is it? Has test value. If it's got a has test value on it, that's a special thing. Okay, we're going to do this. We're going to say, hey, if if we haven't found one yet, then we're going to say we found one.
Whoa.
What's your whoa?
Are we going to put any other code to make sure that it is actually true? Okay.
Yeah, we're going to do that. Then we're going to do, we're going to say, okay, cool. We might do this. We might say, ooh, I got control of the background. Let's do this. New, solid. This is maybe a little too intimate knowledge, you know, having the background access. It'd make more sense to just say like highlight. But you know what? I'm going to just, sometimes we don't do everything perfectly here. Colors dot. Let's make it red for now, but then I'm going to click on this and use Code Rush to change a different color. I'm kind of imagining this is kind of a really light green background for your hint. Like that.
Okay.
Okay, cool. We found one. Now, no matter what, I want to come in here and I want to say, hey, has test value is false. I just want to clear them out. Okay? That's what I want to do. I think I also, somewhere in here we've got a clear method. No, that's not the one I want. One that clears all of the game. There it is right there. Here, it calls clear on the square itself.
On each and every square.
Yeah, I want to say has test value, set this to false as well. Okay, cool. Next, I want to do one more thing. I just realized, see this clear gain call? Hold on.
Yeah?
Yeah, we're okay. Load game is, okay, never mind. All right, we're good. So let's try running that. Now, remember that it's got to complete a full brute force search to be able to get a hint. So it makes no sense to get a hint when there are, you know, trillions and trillions of combinations.
That's true.
Can you run the game? Hit start for me. Well, let's try it. So we have to get to a point where it's,
Oops.
you know, millions and millions of combinations.
This one is 60 million. But when you
Okay,
try to solve it,
try hitting hint. See how long it takes.
Is it unresponsive?
Oh!
Oh!
Oh, it fixed everything? Oh, wait, hold on. You know why? Hold on, we'll get it. What's wrong? What's
We're
wrong?
never clearing it, are we? We're never setting it to true, I mean. Sorry.
We set it to this. Now, it's characters. We're going to say char.new value. That'll clear it. think. On the wrong edge of the string, no, that'll work. Okay, save that. That's what we forgot to do. We're not going to clear the main one that we found. Notice right here it says if not found yet. We don't clear it here. Only if we've already found it do we clear it.
Okay.
Okay? So try it again.
Control Shift, load in. Okay.
So we're going to see that
Responsive again.
1 and 4 turn to a 1 up there.
Okay, so now if we do a hint should be here. Yeah.
Nice. And now hit solve. Now that we have that, see if we can finish it. Interesting. So our strategies, which are essentially based on how we noticed we were playing the game as humans, our strategies work on this one except for at one point where you have to essentially do a guess and go through all the combinations.
Well, that's better now because now if we want to test out, like if we want to test out to see if brute force still works, we can just do hint.
Doesn't clear it? Doesn't change the background color?
No.
That's when we cleared the game?
Yeah, when I reloaded the game. Wait, let's see. Even if I load a different game, it's still...
Okay. Let's try this. Don't do anything. Don't close it down yet. Let's try in our clear, setting the background. I think I want to try setting it to null and see what happens, because I think it'll just go through.
Yeah, that's what we did last time, and then even if it is selected, it will still show the selection.
I want to do that. Set a breakpoint here in the clear, because right now it says, hey, you can make changes while it's running, but when we have a breakpoint, we can. So if we say load game, like that, now we can clear the breakpoint and run it. And now does it go away? I think it goes away now.
Wait, let's see.
Try it.
Control Shift load game. Stop. Responsive. Hint. Okay, now Control Shift load game, and it's on, and I can still show the selection line. Okay, good. It works.
Okay.
Now undo and redo.
Let's check in what we just did. We added a hidden button. Oh wait, let's do one more thing. I want to do one more thing. Every time we click on solve,
Oops. Sorry, was that?
after we call apply solvers, I want to calculate the number of combinations.
Okay.
That's what I want to do. So I want to, let's call a method here that says, well wait, where are we calling apply solvers from? Calling from button solve. Okay, so right here I want to say update combination remaining. That, I'm going to declare the method. I'm going to throw it down at the bottom of the file. I'm going to go grab this, my favorite iteration code right here. Two-dimensional iteration code that iterates through every square. I think I'll grab all the way to there. Paste that down in here. And now what I want to do is I want to say, hey, I want to get the notes. And somewhere in here, I think it's the base group solver. I've got a function here called getNumbers.
Ooh.
We pass in the notes.
Okay.
If numbers.count is greater than 0, and let's come down here and let's say, let's create a variable. I'll make it a type decimal because it's going to get big. And we're going to say num combos, set that equal to 1. Okay? Num combos, numbers.count is greater than 0. Then we're going to say num combos times equals numbers.count. Whoops. Tell me what this code is doing, Campbell.
That code is it's setting num combos equal to itself times the numbers in the base.
That's what that line of code is doing, right? Why am I doing that?
We're doing that. I'm not sure why we're doing that.
So I don't have to hold up my calculator and you don't have to tell me all the numbers and I have to type it all in every time.
We already.
Instead, we're just getting the numbers and we're multiplying it. That's going to tell us the number of combinations that are out there. Essentially, the number of combinations. Sometimes combinations are valid, like I can't have 1, 1, 1 in the first 3 squares because the rules of Sudoku. But it's going to give me a rough estimate of how many combinations I have to look at. Right, but we do look at that as a possibility as we're iterating through. We're saying, oh, does this work? No, this is equal to that one. No, discard it. You know, that sort of thing. Okay, num combos is there. Then the last thing I think I'm going to do is I'll maybe throw it up on the title bar. I'll say title is equal to. I'll do an interpolated string. And why don't you throw something up there using num combos? It's on the clipboard, I think.
Okay. So,
Combinations are with an ion after the B.
yeah. Wait. I got it.
It's ion combinations, I think. Isn't that weird that combos is spelled with
yeah,
an
that's
OS?
so weird.
We don't say combis.
Okay.
One other thing I want to do. And that is what happens if num combos is 1.
Then we're done.
Yeah, I'm going to change it to 0.
Okay.
Let's do this. Yeah, you know what? I'm not going to do this. I asked you to do it. We're going to do that. But I wanted to. My intuition was to make it shorter, so it's easier for people to read. Try to do that with everything. Go ahead and hit start, and let's run it. See what happens when we solve now. System overflow. Value is either too large or too small for a decimal. What's larger than a decimal?
A double decimal.
I think they're scientific notation numbers, but I don't know about them. Switching over to my machine. Let's go look at C#. Numbers larger than a decimal. I think number types. What do I got? I think there's a scientific notation. Yes, decimal. No, but I need something more precise than that.
A big integer. A big integer. Right there. If you need even larger precision than big integer. Really?
I'm down at 4. Let's try it. Woo! I want a big integer. Now I'm excited. I've never used this before, Campbell. It is not helping me here though, which means it's probably in something I've got to use. System numerics. Look at that, Campbell. I've never used system numerics before. Now we're getting into some serious professional coders now. Oh, geez, I'm not even showing you my screen, kids. Sorry about this.
Well.
This is interesting. Using system numerics. It's taking a while.
That's weird.
What's weird?
Why it's taking so long.
I don't know. I almost feel like if I stop it.
This guy froze. Oh wait, no.
I cancel it and try it one more time. I'm just gonna save everything. Try one more time. I've never seen it using take so long before. Big integer, it's interesting here, back over to my machine, while that's going, let's see if that makes it. It says, big integer is immutable, meaning you cannot change it. You've heard of the word mutation?
Yes.
Mutation means you're changing, right?
Why?
Campbell, what are you looking at? Yeah.
I'm looking at your screen with the big integer.
Yeah, so big integer is immutable. Right here. So any arithmetic operation on it will create a new instance.
Oh.
This is, I think, wrong. If numbers are large, this might be crippling on performance. I think what it really means, if you have a lot of numbers or if you're making a lot of changes to them, it might be crippling for performance. I'm not sure about that. That doesn't feel necessarily true to me. I suggest you look into exactly how precise you need to be. Perhaps your algorithm can work with normalized values. By the way, for big integer, it says you have to handle decimal points for yourself. It doesn't, it's just an int. It doesn't handle decimal points. We are unable to bring in system numerics over here on your machine. Let's go back over here. It's still up here like this. All right, I'm going to cancel this. I'm going to drop a marker here. I'm going to manually come in here and just say system.numerics. It's not here. Where do I have to go to get it? It's going to give me a problem with that space.
What if you have to use a system dot something in order to be able to use the system numerics?
Say that again?
Nothing.
Wait, you said nothing? You can't do that.
Okay, I said what if you have to use a system dot something in order to be able to use the system?
Yeah, no, I think you're right. We have to come in and reference maybe system.numerics is what I'm thinking. Let's see if we can find it, if there's a system.numerics in here. Ah, there is.
Woohoo!
Let's add it. Okay, now, okay, cool. Type your namespace, big integer. Now that looks good. Good. Okay, is the code gonna work? Let's save it and let's run it. It means we got a big number. Looks like it worked. Oh no, we have to test it. So load a game. Get us some notes up on there. Hit the solve button. Yeah. Okay.
Oh God.
That's a big number. That's like way beyond trillions.
That's no wait.
Solve it. Every time you solve it, watch that number drop. It's dropping significantly. Now we can maybe, well this is actually, I was going to say, right about now, this is where we can actually use our hint. We should maybe only make brute force and hint available if we have fewer than, say, 50 million combinations.
Maybe fewer than 20 million, because I think it can handle that.
Let's make sure I'm looking at that number right. Yeah, that's 15 million. That's the number I got when I was on the, okay, so let's do that. Let's go in here. Let's say load game. Let's go into, what is it? Is it load game? So in load, whoops. It's my load game. So in load game, let's make the button, whoops. What's happening?
I'm not sure.
Sorry, get to load game. There it is. Okay, we're gonna go to button, brute force dot is enabled, set equal to false. See what I did there?
Yeah.
What am I doing?
You are, so basically, once it reaches underneath, once it's, wait, when it's loading the game,
Yes.
you are disabling it.
Disabling the button.
So when it's first loaded, you can't do anything.
Right, exactly. Exactly. Now here I'm going to say, hey, if num combos is less than 20 million.
What does that mean?
I think it might have been. I'm not sure what happened here. Yeah, if it's less than 20, 1, 2, 3, 1, 2, 3, 20 million, that's what you said you want to do?
Yeah.
We're going to make these equal to true. Okay? We're just basically, look, I'm not even going to try it. I'm not even going to make brute force attack available if you've got more than 20 million combos. Run it and see if it works.
Okay.
Okay, that looks good. You still got like what? Okay, stop right here. 1, 2, 3, is that 19 million right there?
No,
Or it's 191 million.
19 million. Now, it dropped down the combination. It went below. Okay.
Let's try. So let's try this. Let's see how we do at 200 million.
What about the easiest?
Sure. I want to see. I also want to go ahead and do the easiest. Do it.
Solve. Oh right, I forgot.
Now you got to 72.
Yeah, we
we're
can
really
solve
good
this
at-
one in
Right,
3
because
clicks.
our human strategy emulation is actually really pretty good. By the way, Kimmel and I thought of 2 more that we could do that we haven't done yet. That we might do in the future. Let's change it. I want to see how we do it. I'm just going to add 1 0. Okay, that's not a big deal, right? Just add a 1 0.
No, it's a pretty big deal. You're multiplying
I wanna
that
see if it
number by
works.
10.
I want to see if it works. Load that hard game and see what we're looking at if we have 200 million.
Solve.
There you go.
There.
So now we have fewer than looks like we have 191 million.
Yeah.
So you do a hint. Do the hint button. It's going to turn that 4 to 1. That was not bad. It found that pretty quickly.
What about brute force?
Well, same thing. It's just going to do it. Go ahead and do it.
I clicked it. It's. Oh wait, did I not click it?
Oh,
Oh,
wait.
it's just bringing up the notes.
We got that problem again. Look. See the empty squares? Squares with no notes?
Where?
Next to the 2 and the 1 in block number 6.
Oh.
Yeah. Interesting. I need like a refresh notes kind of thing. I think. Actually, wait, is it
We
still
do.
running?
We have refresh all
Let's try
notes.
clearing the notes and then hitting solve button. There we go. Okay. So now it can work. It says like, I think there's a problem with the brute force attack that we are destroying some notes when we should not be. And I think that's the source of the bug. Again, like I said, I'm not worried about it. All right, ready to switch over to undo and redo?
Yeah.
Can you check this in? These changes we did? So we added a hint button and we just improved the UI a little bit.
We added.
I love big integer. I'm like a huge fan of it, Campbell. That means we can do huge things. We can control the world now. I've basically been stopped by controlling
it's
the world. Because
32 bits. It's 32 bits in a big integer, right?
No, I don't think so. I think a big integer, here's my theory. I think a big integer dynamically allocates the space it needs to hold the number. Why would you limit it at this point, right? We're now past the point of just storing, data in memory directly. We're now at a point where, you know what, if you need something bigger than a decimal, we're not going to have you, this is how I do it. I'm just speculating. We're not going to make you, then ask the next question, what's bigger than a big int? Yeah, look at this. Look at this. It says right here. Big integer struct can hold numbers with an arbitrary large precision. Arbitrary means you get to choose, I think. Doesn't matter.
our Sudoku solver can solve any Sudoku, but
Every Sudoku we've thrown at it, it's been able to solve.
but also with the brute force, we know that it is able to solve them.
Yeah, can you go back and run and load up the expert
'Cause-
level
Yeah.
one? Wasn't that one really
No matter
hard?
what Control Alt Shift is, I think the
What'd you say?
shortcut. Control Alt Shift, I think, is the shortcut.
Yeah.
Control Alt Shift.
And the title will say, yeah, expert game loaded. Is this the one, have we tried this one this morning?
Oh wait, in this one, yeah, I think we might not put the limit on when you can use the brute force in the hint.
Yeah. So at this point, solve is done. This
Yeah,
point, we need to really hit it.
We only get 2 8s.
That's a big number. Oh my gosh. But we solved this yesterday using brute force,
No,
didn't we?
No, we didn't. Oh wait, yeah, we did.
But it took like a few minutes.
It did. It took a long time. Yeah, I'm just gonna comment out that code.
Sure.
Where is it? It's in load
It's
game.
in load game.
No matter
There you go, right there. It's
load game.
if you select both the lines and hit the slash, you know that already? Okay, cool. So save that. You want to check that in as well?
I don't think it's gonna be permanent.
Okay, fine. So that's just on your
Just-
machine. On
just
my machine, it
try
won't be
it.
that way. All right, we're gonna switch over to my machine. I'm gonna get.
Control
I'm gonna go get that latest code. Campbell just checked in.
Now wait, I want to try just with the hint, maybe. Uh-oh, is it doing the unresponsive thing? Yeah.
Well, because
It's-
there's a huge amount of combos.
Yes.
But actually, this is really cool what you're doing. So we'll let Campbell do that. While he's doing that, we'll switch over to my machine. Campbell, you let me know when that comes back.
Okay.
Okay? I'm going to pull down Campbell's changes, merge them in. Reload. And now if I run it, I should see those two buttons disabled. Just to verify. Oh, they're not disabled. Oh, because I haven't loaded the game yet. Now they're disabled. Sweet. So I've got Campbell's latest changes. Okay, let's go. Let's talk about undo and redo.
Okay.
And we'll talk in the process of doing this. We're going to talk about the command design pattern. So design patterns, Campbell, are actually they are solutions to problems that developers hit all the time. As an example, just hit continue on your machine, Campbell. They're solutions to problems that developers have all the time. Let's say we were an architect.
Yeah.
And one of the things we do all the time is we put doors in, right? We install doors. Every house we build needs a door, right?
Uh-huh.
So we might come up with solutions like something called a shim, which is a piece of wood angled like a wedge that allows me, like I can kind of use a hammer and nail it under the door to kind of orient the door, get it the exact right height and angle, right? So that I can put everything in. And we might now, if you and I are both architects, I might say, hey, I used a shim the other day, and you're like, a shim, what's that? And I say, well, shim, it helped me do this thing to put the door in, right? And you're like, oh. And as we talk about the problem of putting the door in, and we talk about the solutions involved with that, we both end up deciding that, you know what, we're going to call this a design pattern, because this is a problem that every architect has, how to put the door in.
Yeah.
Okay? So the phrase design pattern means it's a solution to something that a lot of people have a problem with. And the cool thing about giving it a name is that now I can talk to, maybe I'm talking to somebody else who's also an architect, Joe the architect. I'm saying, hey Joe, you tried out the shims yet? And if he has, he knows about it, knows the name, he's like, oh yeah, you bet. It's a shorthand now, once we know the name. So labeling things is actually something the human mind has a tendency to do, give it a name. And once we do, we've got a shortcut for discussing it. Make sense?
Yes.
See the value in having shortcuts for things?
Uh-huh.
Because otherwise I gotta be like, hey Joe the architect, do you stick a wedge piece of wood underneath the door and use a hammer to tap it in? You see what I'm saying? It takes a long time to describe.
Yeah.
Okay. So one benefit to having a named solution is that there's very quickly I've got shorthand. I can talk to you and get it. There's another benefit to it as well, and that is that you and I can go to lunch and talk about it and add our thoughts to the community consensus on what the best solution is. Does that make sense? We can study it.
Yeah.
By putting it out there, we can study it, we can understand it, and we can talk about our preferred ways of implementing it. One thing I want to watch out, I want to warn you on, and this is, and two things. One is your mind's still growing, right? You've got a young mind, and one, and number two is there's a tendency with anything that you learn new that's got a name to want to use it everywhere. If I say, hey, here's a hammer, and then you see a screw, you might want to try to hammer the screw in. Does that make sense? There's a tendency to overuse a new solution anywhere because we want to find meaning. We want to associate meaning with that which we know, and we want to find an application for it. So one of the cautions that I want to give you is that, hey, when we learn design patterns, sometimes there'll be a tendency to say, hey, can this design pattern solve it? And you'll want to try to use the hammer design pattern for everything to turn screws.
Yeah.
You with me on that?
Yes.
So the warning is, okay, we're going to learn it, but we're not going to maybe make it the thing we use all the time. It's only if it really, really fits. Does that make sense?
Yes.
Okay, we're not going to use shims to screw in screws. We're going to use shims to level the door. That's what we're going to do.
Yeah.
Okay? All right. So the first design pattern we're going to learn about is called the command design pattern. Okay? And the essence of the command, ignore the slide for a second. The essence of the command, let's do this. I'm going to create a new slide so it's easier to ignore that slide. So we're going to just talk about the essence. What's the essence? Well, it decouples the doing, the execution of things, the execution from the app doing the execution from the caller, from the client. Maybe I'll call it the client. So the client, in the sense of, well, have you heard the word client before, Campbell?
Yes, I think I have.
So, go ahead.
Talked about it.
What'd you say?
We talked about it a little bit.
But have you heard it in the regular space of the world?
Yeah.
What does client mean to you? Do you have a sense of what it means?
A client is like someone who buys from you or uses your service or something like that.
Yeah, exactly, yeah. And so like here is, I'm making just like a person right here, and that's going to be like our client, is kind of the idea. Well, in software, there's a similar kind of thing. I can have some super code out here, some awesome code like my solving code, right, we wrote.
And then there are the things that use that code.
Yeah, and that's the client. So my client is going to make a call out here and solve it. That's the main window is essentially what the client is. Usually it's the main window, right, is what we call that, right? You know what I mean when I say main window?
Yes.
Right, it's that main window .xaml.c# file, right? Typically what it is. So this is the client. And I'll put main window in parentheses like that. Maybe make it a little bit bigger. Make that font a lot bigger, like that. That's the client, okay? So it decouples the execution from the client. So instead of the client saying, directly going in, like we're changing values, we're just changing them right in the data, right? When you type in a number, it puts it directly into the, I said right in the data, it'd be more accurate to say it puts it right, it tells the control to change its data, right?
Yes.
That makes sense? Also, the control's got event handlers for what you type in. And actually, you know what? I think I spoke wrong twice in that sentence. I think that sentence was filled with misinformation, so let me retract it and try again. When you type in, the control knows you're typing in, and it changes its text.
Oh, so...
The control knows you're typing something in, so it changes its text automatically. It fires an event that says the text has changed.
But it just appears that when you type it in, it's taking what you typed in and putting it in.
Yeah, that's what the control does, essentially.
Yeah, it's not really like directly... When you hit a key, it detects, oh, this person hit this key, or sorry, this key was pressed.
Yeah.
Change the text to include this key.
That's what the control does.
Okay.
So the control does that automatically. And it's not helping that our data is in the user control. That's a slight problem that we have. I'm going to try and work around it, but it's a slight problem. So, but the essence of the command is it decouples execution from the client. Instead of the client saying, hey, go solve the code or go change this value, we're going to have something else change that, do that. There are 4 participants in the command. The decoupling breaks it apart into 4 places. There's the client, right? Which now I'm going to use this as my client for my icon there. There's my client right there.
So, yep.
Drop it down, drop the font. It's tiny. There we go. There's my client. And then over here, paste that client back in. There we go like this. Whoops. Okay, so there's my client. And so I've got the client. I've got the command. These are the most important parts, these 2 right here. And then you've got what we call the receiver. That's the part of our code that can do something. The receiver in this example is this thing, solving code. So we'll call this the receiver. Like this. And so this is what it looks like here. This is tightly coupled. This example is tightly coupled right here. Does that make sense?
Yeah.
This is tightly coupled. Coupled means connected together. And we're turning something so that it's not tightly coupled. Instead, I go to an invoker, and I can add commands to the invoker, and I can also, will eventually be able to do undo and redo. The invoker is going to hold on to all the commands. It really usually only needs 1 command at a time, right? When I say add a command, what I'm really saying is do this command. And the invoker says, okay, cool, and it bundles it up and does it. But the cool thing is now that I have an invoker to do every command, that means I can now add undo and redo very easily right here.
Yeah.
Inside the invoker. It also means I could log every single command that takes place. So we could have a history of every single thing that happens.
Ah.
Okay? Command has 2 components that are inside the command. It's got a reference to the receiver, like my solver, right? Remember my receiver is the solve the code, that sort of thing. So it's got a reference to my receiver, and it's got some data. It's got everything it needs to do the command later. Now I say do the command later. When we say, when you type something in, we're going to do the command immediately, but the client's just going to give the command to the invoker and forget about it. That's what it's going to do.
Okay.
Okay? Tell me your thoughts on all this. What's your gut level reaction?
Well, how... I guess basically my reaction is so the invoker in each command, it holds the commands, and then the commands hold the receiver, but then what does the client do?
The client only does these 2 things. It says, hey, add commands, which also is the same as do something. Do command, maybe. Right here. And then the client goes to the invoker and calls undo and redo.
Okay.
So let's do this. Let's create a slide and we'll call it questions. How does the client, it's a great questions, interact with the invoker? And I kind of give you a short answer here, but let's keep the question up, and we'll take a look at it in closer detail. Any other questions? We'll just write them down. We won't answer them necessarily right now.
What else can the client be besides me?
Okay, cool. What else can the client be? What else can the client be? besides the window? Good question. I love it. Any other questions? Do you want me to, I can answer some of these too right now, but I'm also liking this idea of just getting questions right now.
I don't think so. No, not right now. I don't have any more questions.
Okay. I have a question. Why did Mark / Dad put 3 commands in the invoker? Why does it seem like it has so many commands? Shouldn't it only have 1?
But each command has different data.
Whoops, I didn't copy everything. Ah! One of my least favorite things. Point is here. Okay. Why are there 3 commands in the... There are 3 or multiple commands. Maybe it's a better way of describing this question here. Why are there multiple commands in the invoker diagram? Shouldn't it have only 1? Like, why would I have several inside the invoker? Because we're just doing 1 command at a time. Okay. Any other questions?
Then we finally did it.
Oh, we're done?
Yeah.
Okay, cool. Let's switch back over to Campbell's machine.
Yeah.
Here we go. So give us a hint.
Yeah.
So it actually can solve that many in not too bad. Not too. It's a fairly reasonable amount of time. That's a ton of combinations. It's not going. Now here's the other thing. It's not going through all of them to necessarily solve it. But all right. So let's keep going. Can you move it so it's a little more centered because the coins are blocking the side of it a little bit?
Yeah. So,
cool.
So now all we have is this. Oh wait.
You see how many
So
combos
we have
are left?
3, 6, 8, 3, 8.
Nice. That's what
So
it's
we have
given
a
us.
couple of more digits, but still not too many.
But can we solve it? Oh, we're broken again. Is that right?
Can't do anything.
When I say broken, we're not moving forward. Is that right?
You can't move forward using the solve button anymore.
Okay, so so interesting. So this is this one. This is the expert level one.
Yes.
Okay, so it has 1 that we've had to guess. We still, by the way, Campbell, we still have that other rule. We have 2 more rules that are pretty clever that we can add to our solve button up there that I think can help get us through this faster. We haven't done that yet. Remember?
No.
We talked about it on the
yes.
whiteboard I think yesterday.
Yes.
That if we, it takes a while to explain, but we'll, I think we'll do it maybe next Friday. So hit the hint button again then. All right, you did it?
Yep.
Did you do it? Okay. Switching back over to my machine. Okay, any other questions on this, Camel?
No.
I love that we're asking questions in advance. If you have any other questions, we go along. We might add them to this page.
Well, what exactly does the receiver do?
Oh, love it. What a great question. That's an awesome question. What exactly does the receiver do? And this one I kind of want to give you a little bit of an answer in advance on that. Is what I want to do. And the receiver, it does whatever it's supposed to do. It solves things. It adds things. Whatever the part of your code ultimately does, the receiver is normally the piece you would directly talk to anyway from the client.
Ah.
So that's what the receiver does. So let's, yeah. So that's what the receiver does. Yeah, there's the receiver. I've got it in purple here. Let's take that and come in here and put the format painter there. And do this like that. There's my receiver, right like that. Okay, so we got everything color coded. Make sense?
Yes.
Okay. For example, it solves Sudoku. So does that make more sense? What does the receiver do?
Yeah.
I still love that we have these up here. We should do this every time we start something new. because I want to come back to the questions, right?
Okay.
So we say, and we get a sense of, what's cool about that is we get a sense of, well, how much are we learning?
So
Go ahead.
the receiver basically does what the code does.
Yes, receiver does what the code does.
Basically executes it.
Yeah, it does something useful, is what it does. All right, cool. All right, let's go to. All right, excuse me. So we need to start decoupling. I think I'm ready to just start writing code. So, and I'm not exactly sure. I thought we'd do this on my machine, Campbell, because I think it's going to be like, we're going to do a lot of code, and I don't want this to be about like, I don't want your newness to like both the keyboard and coding to slow this down. I want to look at this more from a kind of a architectural perspective. So we won't worry about the writing of the code, or at least you won't have to as we build this. So, what'd you say?
All right.
So we need to build a couple things. We need to build a new class. I'm going to build a new class called a command, like this. And I think I'm going to make it abstract, which means it has no constructor, which means we'll have to create a descendant of it. I'm going to give it a method. That is going to be. I think I have a template in here. No. All right, I'm going to give it a method called execute, like this. And I think that's it. I'm going to make this abstract as well. So descendants will have to override the execute method. What's my problem here? Oh, can't be private. I'm going to make it public. So that is my command. Okay? Any questions on that class right there?
No.
So I'm just basically saying, hey, any descendant of this is going to have to be able to call execute. All right, you good with that so far?
Yes.
Okay, good. Next, I need to create my invoker. I don't really like the name invoker, by the way. That's what the design pattern calls it. I kind of want to call it something different, but I need your permission, Campbell, to do that if we're gonna go that way.
I have my permission.
You're okay with that?
Yeah.
So I want to call this my command manager. Is what I want to call it. So I'm gonna create a new class, call it command manager, like this. Okay. So you know what I'm gonna do?
Oops.
I'm going to take this guy, I'm going to copy that thing to the clipboard. I'm going to, you got another result? Another hint?
No.
Oh, not active yet? Okay. I'm just going to paste it in here, cut it to the clipboard, then come back in here, and I'm going to do this for you. Okay? Like that. I didn't like that it took the, didn't do the edges don't look great there. I wonder if I can copy it here and paste it in here. Any better? Yeah, it doesn't look as good. It doesn't do the text well. It nails the outside edge, but it just destroys the text in that conversion. Seems a little bit better. I guess we'll just keep that one. All right, so there's my invoker right here. Just to remind you that my command manager is my invoker. Does that make sense, what I'm saying?
Yeah.
Okay, so there's my command manager. I'm going to move the type to file. The command manager is going to, I'm going to make this static. Okay? I don't think I need an instance here. So just one of these is going to survive for the duration of the application. And the one thing was going to be the static class, because it's always just one of those. Now, inside here I'm going to have a method, do command, like that. And it's going to take a command as a parameter. Like that.
Okay.
All right. How are you doing so far in terms of, following this, understanding the complexity of all of this?
I'm following.
Good so far?
Yeah.
All right. Now what it's going to do, it's going to come in and say command dot execute. Boom, and we're done. Follow it?
Yes.
Got it? By the way, when we decouple anything, Campbell, when we decouple code, often when you first look at it, it looks ridiculously simple. It's almost like, wait, it's like me saying, it's like this, Campbell. It's like somebody asking you to do something that they could do themselves. Do you know what I mean? Like, it's like kind of like saying, hey, like if we're watching TV and I'm closest to the light switch and I say, hey, Campbell, can you turn off the light? It's like that, where you have to get up, walk around, and turn off the light. Do you know what I mean?
Yeah.
It's a little bit like that. It's a handoff.
We got a new hint.
Do you have your hand up? Oh, we got a second
Yeah.
hint? Switch to your machine. Let's take a look at it.
And now we get a couple more digits.
And we're blocked again?
Yeah.
Oh, this one's a hard one.
You get blocked right here.
I wonder.
We still have a ton of combinations.
Yeah, I also wonder if our brute force attack is. I wonder if there's got to be a smarter way to do this. Because you wouldn't expect the human mind to go through all these combinations, right? There's got to be some way to tell in advance that you're approaching a dead end and backing away from it. Did you just hit brute force again?
No.
Was there a hint again?
I haven't.
And so solve is not doing anything now, is that right? When you hit solve?
Yeah, when I hit solve.
Can you also clear notes and hit solve for me? I just want to make sure we get the exact same notes coming back up again.
Notes, solve.
Okay. Okay. Get another hint. I love that it's keeping them green though.
Yeah.
Right? It tells us where we're...
I've hit it. We're locked up.
Okay, cool. We'll come back. All right. So far it seems kind of like somebody saying, hey Campbell, could you turn off the light? And you're like, all right, I'll go walk over here and turn off the light. Do you know what I mean? It's just like that right there so far. Okay. We don't have a receiver yet. We don't have that. We need to kind of build that into it. But we've essentially got the essence of it. We've got command manager.doCommand. And I could rename this invoker, I suppose. Yeah, I don't want to call it invoker. I really don't, because it's so generic of a name. Command invoker. Holy cow, I'll call it that though. How's that sound? Everybody happier now?
Yeah.
Command invoker. Okay? And so we're going to say do command is still, we'll still keep that piece there. And we'll call command.execute. That's what we're going to do. Command is currently abstract, so we're going to have to create a descendant into this. Now, next we need to actually look and see where things change and decide how we're going to make that, how we're going to accommodate that change. The main thing we're talking about here is when we run this, I'm just going to run it on my machine here. When we run this,
we got a new hint.
Got a new hint. Well, that's good because there's less time now. There's fewer of these. And now let's see how we do it. Okay, so we could get all the way through
with only 3 hints.
With 3 hints is that we needed. So that's pretty tricky. Pretty tricky. I'm really kind of so what's interesting is our 2 new rules is to see if our 2 new rules give us anything. Right? Before we add the rules, we should check to see count of how many solve clicks it takes. You okay, buddy? You want to do something more exciting? You look like you're tired. Yeah, you okay for sure?
Yeah.
All right. What do you want to? I don't want to be, taking the conversation all the time. Let me back away and you tell me what you want to do. You sure you want to do undo redo?
Yes.
You're still in it? Okay. All right.
Because once we do that, I think it's going to be much easier to tell how, where, I guess, how much progress we're getting, I guess.
All right. So let's say I come in here and I make a 4 here. See that? That change?
Yeah.
See that?
Yes.
Okay, yeah, you just gotta say yes, then I'll keep talking. So I made that 4. We need to essentially make that change in a different way than we're currently doing. Now, I said this was tricky because we're actually typing in to the square and making that change. So let's go look at that and how that's working right now. I think we have the text changed somewhere. Value text change. So we have this right here. this does trigger an event on value change. The problem is that what's happening here is we're basically it's kind of very, very tightly coupled and it's very internal to the text box is what it is, kind of what's happening here. We're assigning a new value here, and then we're calling on value change. Is what we're doing. What these two things kind of almost need to change to is a call to the invoker. And so we said before our client code was main window, but it could be anything. Our client code could be anything that can see the command invoker. So I think what I want to do is this, is I want to say command invoker dot do command. Well, eventually I want to do this. Then I want to do a new text change command, which we don't have yet. I'll build it. And then we kind of pass in the data. The what changed. Like that. But we also need to know where it is and what is changing. Does that make sense? So
Yes.
we need to know what square we're in. We don't know that. The Sudoku square doesn't say what square it's in.
Yeah.
Somewhere in here, I think we had a bunch of these. Okay, oops, I think I passed it. Right? Oh no, that's a new array. Sorry, I didn't pass it. Looking for a new instance of it. Featuring coders that will get me there quicker. I'm just trusting that I'll tap the next reference and find it. No.
Uh-oh. That's...
Well, we do actually kind of know where it is. It's got an attached property to the grid. Based on this instance, it tells it what its column and what its row is. I'm going to use that, Campbell, to find out where I am. Because I need to find out which square to change. I want to specify that. So let's get back to here. Where was that? Here we go. And I want to create, I think, I want to create a read-only property type integer, call it column, like this, and then I'm going to go into the grid. I think I can do what is it? Grid column. No, it's grid dot get column of this. Sweet. That's going to get it to me. That's an attached property. I haven't talked about attached properties, Campbell, but they're basically a way of, instead of putting the property inside of you, we put it inside of a dictionary and we pass you in. That dictionary is the key to that property.
Oh.
So what that allows me to do is, instead of having to change your code, I can just attach a property to you. If I've got a dictionary. So if I've got a dictionary of columns, I can say I want to put Campbell in column 3. I'm going to say, okay, in my dictionary, add an entry for Campbell and stick him in, set his value to 3. And now you're in column 3.
Okay.
So that's kind of what's going on. The grid, that's what's going on in the XAML. So in the XAML here, when we say grid dot column, where it's an attached property, and it's attached to this instance, this tbx3_4.
Okay.
So now I'm able to pass in the row and column here. So now I can come over here, what changed, pass in row and pass in column. Like this. Sweet. So we're not doing this anymore. Got it?
Yes.
We're not going to do that there, and we're not going to do it here. That's now a no-no. We're not going to change the text directly. Instead, we're going to go to the command invoker. We're going to say do a command, and then we're going to do that. Let's go create a new text change command. Let's declare that. That's going to descend from command like that. Let's implement the abstract class, which means we have the override of the execute method. Okay. We also said we wanted to create a new instance of this, right? We're passing in 3 parameters to it. Let's declare that. We'll declare it with properties. Okay. So now we go in here, we have these 3 properties. What changed, row, and column. With me so far?
Yes.
Okay. So that just creates a new instance of it. It's, again, very much like saying, Campbell, go turn off the light. And then you get up, you walk, around, and you finally make your way to the light, and you hit the button. You hit the switch. Okay? So it's a lot of effort so far. We haven't executed yet. We need to set a breakpoint in here. It's kind of what we need to do. There's one other thing we need to do, because nothing's going to work yet. We need a reference to the squares, all the squares. Right now we're keeping all of that inside main window. We've got this variable called squares here. See this here? It's in main window. You with me?
Yes.
It's cool, but I can't get to main window from my command, my text change command. I've got no main window here. And I really don't. I don't want to do that. Instead, I want to put squares in another place that's super cool. Okay? So what I want to do is I want to create a new class, and this is outside of the command design pattern. It's just part of decoupling, right? The things that are stuck in our window, we realize, we should really put them in another place. Organization is going to save you as a developer, right? If you're writing code, having code that's well organized is going to save you, and having code that is not is going to harm. Is going to bring harm. So I'm going to create a new class, and I'm going to call this the Sudoku. I'm learning it. Sudoku board. That's going to be my class. And it's going to be a static class, I think. Like that. Okay?
Okay.
Which reminds me, I think my command invoker. Let me go look at that. Yep, static. Okay, cool. Sudoku board, it's going to take these. It's going to take selected square as well. I'm taking both of those in there and popping them in here. Okay? That's what I'm going to do. And I'm going to make them both static. Whoops. ST for static. Like that. And I'm going to make them both public for now. Just like that.
Okay.
Okay? So now everywhere in here, look at this. Oh, brother. We need that. Wait, what's going on here? Let's look at the square. Hide selection on the square. Show selection.
Wait, we can just use the find and replace, right?
Nope, I'm not going to do that. We could, but I'm not going to do it. I'm wary of that because it can introduce problems. I'm not making that one private. I'm not making that one public. I'm making this one public with this. So now I've moved the same property over. So the property's got cool side effects like hide selection, show selection. So this is sweet, right? This Sudoku board is now gaining only the properties and behaviors of the Sudoku board. So we'll come in here, main window, we're going to do that. This could actually be a method in here. We could be like this, select first square. Yeah, the organization of this turns out to really, it becomes this kind of beautiful thing here. All right, let's do that. So select first square is now there. So now we've got code that's a little easier to read here. Initialize. Here, I am going to do search and replace here for all of these. I think I'm going to turn this into a method, Campbell. That's what I'm going to do. I'm going to say, yeah, let's do that. So we select them all like this is a rectangular selection. Paste in, say Sudoku board dot add square. Open paren. Like that. Oops, I did enter. I didn't want to do that. And then here, turn this to a comma. And then go to the end and add, turn all of these into closing paren. Like that. So we're going to call add square. And this is going to be row, column. And we're going to say square of row column is equal to Sudoku square. Questions on this? It can even be, hey, I don't understand, I wasn't paying attention, I don't know what's going on, I hate design patterns. I'll take anything at all. Just want to make it a conversation. Thoughts?
Well, why was it saying that it was wrong when we had
Why were all these wrong?
No, not those. I understand because we haven't declared it yet. But why was it saying Sudoku square?
I don't know. I'm not sure where you are. Ask me that the minute you see it. Okay, if you see it again.
There, exactly there. Because
I took this property out of here and I put it instead in Sudoku board. I've moved it, and in Sudoku board is static, so I can just reference the class name. It's like cookie rather than instance.
Wait, but if it's in the class, couldn't you just?
It's in a different class. I'm in main window, and I put it over in what is it? Put it in Sudoku board.
Oh, okay.
Which doesn't even look like I've moved it to its own file yet. I think it's in this file, but it just can't see it. So visibility is like a big thing. All right, so just going through, I've got some issues in here, there. I don't want to do search and replace because I don't want to mess things up. I'd have to at least look at every single one, and I kind of am just a stickler for using my eyes on each one, verifying that it's the right move that I want to make, confirming it. Right, it's a kind of meticulous double checking that I believe reduces the overall number of errors. Okay, that you've got 15 errors. This number down here, it's right behind you, Campbell. Can't see it on the screen, but it is here. Let me zoom it in here. There it is, right there. 14 errors right there left. Okay. All right. Working our way down. Here's a big chunk of the 14. This could be a method inside of Sudoku board. Toggle conflict. Oops. Toggle has conflicts for selected square. Thoughts on changing this to a method? What do you think about that?
I think we might want to change its name because it's very long.
Okay. Tell me what you want to get to. What do you call it? Toggle conflicts?
Yeah.
Marcus, voice programmers out there, is there a shortcut key to move to the next issue? I have no idea. Oh, he says there is. I have no idea what it is. I wonder if it's that F8. I think it might be F8. I haven't tried it. So let's say toggle conflicts.
Yeah. And then just without for selected square, I think. That's kind of...
Or, you know what we could do? It's an even better solution than this. Hold on. What if we did this? I like this better.
Okay.
So we declare this inside here, and we're just going to say has conflicts. Has conflict equals not has conflict. Got it? Does that
Yes.
look right to you? Okay, cool.
Well, it says no issues found.
Yeah. Let's go back into the Sudoku board. I don't need this toggle conflicts anymore. That's unneeded. Okay. So now I got my Sudoku board. Sudoku board. And there it is there. I've got 10 issues left.
There.
Whoops.
Dot.
Looks like I missed the dot up here too. Okay. Let's try hitting that F8 key.
F8? What does
Yeah,
that do?
I thought that was going to take me to the next issue, but it is not. All right. No worries. The file's not big. 7.
I would say it's pretty big.
6. 5. 4. 3. 2. 1. Where are you? Oh, that was it. The last one was only 2. Okay, cool. So now we've got Sudoku board out. Let's put it in its own file. New type to file. So now we've got this really simple class called Sudoku board, right?
Yes.
It's out in the middle of nowhere. Sweet. Now that it's out in the middle of nowhere, because it's static, there's only one.
Why is it out in the middle of nowhere?
Well, it is. There's nothing else next to it. There's nothing tightly connected to it. It's just this code. Right, I can zoom out and we can see all the code from the class right there.
And how do we then, if there's nothing tightly connected to it, how are we
How are we going to call it? If I tap an X reference to the class name, you can see how it's being called.
Oh.
Right there.
Oh, so it is kind of tightly connected.
Okay. But it's not the data, the things that all the data and all the methods that we're working inside of that are now inside of Sudoku board used to be in main window. That's not in main window anymore, which means now, now in our text change command, when I go to execute, I can actually come in here and say change text now, and then we're going to pass in my row, my column, and what changed. Okay?
Okay.
Now we're going to declare that in the Sudoku board.
All right.
Okay? Are you comfortable with everything that's happened so far?
Yes.
Okay, it's not too bad. Now in here, what we need to do is, well, we need to come in. We've got the squares, right? Squares of row and column. Now we need to do this. Text. Set text is the option. Is that what we want to call? I think it is. And we're going to call pass in what change. Okay, like that. Set text is here. Value is equal to text. Who else is calling set text? Add values for line. This is when we load the game. This is called from loading the game.
Okay.
Let's change this. Oops, sorry, not add parameter. That's all I wanted to do. Let's change this to load values for line, so we know it's part of load game. Okay, so set text is there. Cool. Got change text here. To
Where
what
are
change?
we calling change text from?
What'd you say?
Where are we calling change text from again?
The execute of the text change command. So it's kind of like this. It's like, hey, Campbell, go get up and tell your friend Eli to get up and go turn off the light. It's a little bit like that. So now Eli's an expert at turning lights on and off, and you're an expert at talking to Eli and asking him to do stuff, and I'm an expert at talking to you. So I don't need to know who Eli is at all. The light just gets turned off. But by decoupling now, it now allows us to approach complexity and do some really cool things. Because you can now become an expert at undo and redo. And you don't need to know anything about commands. You just become an expert about undo and redo.
Okay.
And Eli can be there, but also maybe Joshua's there as well. And Josh is like doing stuff. And then you've got maybe Tristan there. And Tristan is good at like maybe doing tricks. And Josh is good at cleaning. And Eli's good at turning the lights on and off. But you can implement undo and redo and I get to just basically say, hey, do this, oh wait, something didn't work, undo, and you know who did the last thing, and
so I can
and because you store it on a stack and you pop it off the stack.
Right.
Does that make sense?
Yeah.
Okay, so finally we get to the change text. Now let's review. How did we get here? We started out, I think in Sudoku Square, in its text change handler. So here the changes occurs, and now we do this. Now one of the things that's happening though is we are calling on value changed from here. I'm gonna kill that. We're not gonna call it from there anymore. So we're not. That's the event. We're triggering an event. I'm not gonna tell anybody anything changed there. Instead, I'm gonna put it in set text right here. I'm gonna put it there, and I'm only gonna.
Why?
Why? Because now this is the last thing that happens. The text doesn't change. The text didn't change up here. And I was calling it up here, Campbell, right there, but the value hadn't changed yet. Okay? Instead, I want to do it down in the set text method right here. But I want to do one more thing too, because I want to do this. I want to check to see, hey, just one more check.
I love the part of CodeRush that when you, I think it's either if you escape to a marker or you tab to something, it does
the locator beacon. Yeah, it's great. Yeah, we have CodeRush running in another product called VS Code, and no locator beacons there, and I miss them. I'm just like, ugh, come on. It's just harder to do that in that environment, so we can't do it yet. But so now what we're doing is checking to see if the text is equal to it is. We don't need to do anything. If they're different, we're going to set the value to the text, and then we're going to call in value change. I think it's going to work and run without us doing anything. Let's see if it runs. And there should be no difference from what we're seeing already. So if I load the game load worked. So all the set text calls came in. Let's see if we can change here. 4. There you go. Cool. Although we used to be able to see problems. Why aren't we seeing the problem? That is a good question.
Are you sure it's on your device?
Huh?
I thought we only had the code on mine. On my machine.
Yeah, Marcus Boyce's program says I was looking at an extension for Visual Studio Code that had numbered bookmarks. We've got that. Yeah, we've also got. We're coming out with templates for VS Code, which we are working on. I don't know. I can't promise, but it's like maybe 2 weeks, roughly, give or take a week on that away from coming out. I think probably about 2 weeks is probably realistic. It's very close to being done. We're just going over everything with a fine-tooth comb, and I think you're going to like it. Based on what we've seen that's out there, it looks like it's going to be the best templating solution for VS Code, and it's going to be free. There's going to be no charge for this thing. I think you're going to like it. So anyway, we'll talk about it as we get closer to it. All right. Well, we got to figure out what's going on. It's like the on value change isn't getting triggered almost, is what it seems like. Well, let's set a breakpoint here. And let's actually set a breakpoint. Let's follow and trace the whole thing around and make sure that it's actually working. So here's where we create a new text command. And here's this command in here that does it. So we've got 1 of 2 places to do that. There. All right, and we'll follow it around. Oops, I meant to put it here. It's not giving me a breakpoint here.
Why? Oh, I think is it because there is a marker there?
No. It's not. I'm going to stop it and try running it again.
Oh, wait, the breakpoint's there.
Yeah, I think I wonder if I made a change to a line of code up above, maybe. All right, so let's do load game. Okay, we're going to get a bunch of breakpoints here for each square that it's setting. I'm just going to hit F5 on each one of those just to run past them. I'm going to come in here and I'm going to put in the number 6. We didn't get the event. We didn't get a breakpoint. Why did we not get a breakpoint? Let's look at our text change. There it is, okay. New value text change. Put a breakpoint there. Find out what's happening. Make it an 8. Okay, step through it, see what's happening. Okay, we got some changes. It's a text box. There it is, there it is, there it is. Text box is not equal to what changed. Text is, well, it actually is equal to that. Yeah, okay. It is equal to it. I think I want to call this no matter what. Because no matter what, we were calling the other one. We were calling, and the other thing I got to take away is in our set text. I got to take away this. We're going to do it no matter what. Okay? Because what's happening is the text box is saying, oh, I'm fine, I'm an 8 now. Because I have the whole thing selected. So that's what's we're gonna do that there. Then here, I think I'm going to. What do I do here? Do you want to say something, Camel?
No.
I'm thinking about deleting this check as well. Yeah, I'm going to delete that check as well. That's what I'm going to do. So what we used to do is set these. I think this is going to fix the bug. That's what I think is going to happen. Let's run it. And I have enough, my intuition tells me this is going to work. So let's come back in here. And now let's change it to a 9. And let's follow it through. So we come in here. We say, invoker, do command. We create a new text command. So the first thing we do is we create the new text command. What changed? And we've now got a 9. That's what I typed in. We're in row 2, column 4. Just set the data. That's all I do in the constructor. Pop back out. So I just drilled into this selected bit of code, Campbell. See that?
Yeah.
Okay. Next, we're going to pass the result of that into do command. So now we're in do command. There's the text command we just created. See, row, column, and what changed. See it? See it?
Yes.
And the type is a text change command because it can't be a type command because it's abstract. Remember?
Oh, and
we said it's abstract, so nobody can be that. It's only can be a descendant of it. But now we're immediately calling execute on it. So now we go in and call execute, and now we go to Sudoku board, change text, passing in row, column, and what changed. Got it? Now here we're going to get that square, and we're going to call set text on it, passing in a 9. Now we set the value, it's already the same, it's okay. And we're going to call all value on value change. Now we're going to other parts of our code. We had this event on it, hey, when change, say show conflicts. We weren't calling that before. Now we're in show conflicts, we're going to clear all of them, go through here, check for conflicts, I'm just going to hit run, and there you can see the problem. Okay? Cool?
yeah.
Let's clear the breakpoints. So we've made no functional changes to the code. But boy is it better. This code is much better than it was before because now we can add undo much easier. Hit a 7. See how it's all working now?
Yeah.
That's just what we want it to do. Okay, cool. Now we are not. We only have a portion that's working with the command. A portion of the change to these is working with commands. The part that's not is the brute force and the hints. Those are not going through the command architecture yet. They're directly reading and writing from the Sudoku square.
Oh, they are.
Remember, we haven't changed any code yet. It's only the text changes, but that's okay because I just want to point out we haven't done the whole app yet. We've only converted a part of it over to the new architecture. I just need you to conceptually understand that and have that make sense. Does that make sense to you?
Yes.
Do you have a question about that? We're not done yet. We've only done the editing and made it participate.
We've prepped for doing it.
Right. Right. Okay? Now, if we want to do undo and redo, we need to basically have a command. We need to either do one of two things. We either needed to create the redo command and give it to this guy, or we need to make this thing reversible, where it can go both forwards and backwards.
Ah, that's true.
Okay? Because in order to go backwards, I need to know what the text was before we got here.
Yeah.
Okay? I'm going to make this one reversible, I think. You cool with that?
Yeah.
Okay. All right. I'm going to make it reversible. The other option is to create a separate command. Go ahead, what?
Couldn't we just make the place where we call this from reversible? And wouldn't that be easier? Oh.
We do this. I'll show you what I mean so you can see this. We can add an additional parameter here. Yeah, it's actually simpler if we make this reversible. I'm going to make it reversible, is what I'm going to do. And so I'm going to add one more parameter here. I'm going to call it the previous value. Like that.
Why is it simpler to do it here?
Why is it what?
Why is it simpler to do it here?
Because if we don't, we have to create a separate text change command passing in the same row and column again. So we need one to go forward and create a second text change command to go back, which we could do. However, I'm thinking let's make this one smart enough to be reversible.
All right.
Is what I'm thinking. Then that saves me, this line of code here doesn't get so long.
Okay.
And then this is going to be the old value, the previous value, which I think I can get from E. I hope I can get from E. Now, changes. Dot. These are the changes. Yeah, I'm getting a text change here. What's the first change? So maybe I could get it from text change. See what the old value was. Moved length, added length. Yeah, that's going to be tough to find that there. I'm not sure. I'm going to put in an empty string here for now. I'm going to set a breakpoint here to see if we can get the previous value of what it was beforehand. I just don't know if we can get it at this point, by the time the event is called. I could do this though. When it gets focus, I could save it. I could hook an event to when it gets focused. Got focused, see that right there, Campbell? See the event icon, the lightning bolt?
Yeah.
That event is called when this gets focus.
So when you
click on it. What I can do here is I can say, I can create a field variable called last text or last value, and I can set that equal to I can set it equal to, I think I got to do a sender as it's tbx, actually it's just tbx value dot text, like that. Let's make a string variable there. Let's turn this into a method. Call it save last value, right there. And then in our set value, set text method here, I'm going to do this, save last value. Call it there as well. So when it gets focused or when we change the text, we're going to save the last value. Now that I've done that, I can use that and pass it into the parameter here. I'm going to create the new text command. So that's my old value. Whoops. Right there, passing that in. Cool?
Yes.
Are you excited? All right. So now we're going to come in here. We're going to declare a property with an initializer here. That's my previous value. Now I just need a new method called undo. It's going to be a lot like similar to execute. What's going to change in it?
What changed?
Yeah, what am I going to send instead?
You're gonna send it previous value.
This is exactly what I'm going to do. And it says, hey, you can't override it, but I want to actually. I want to have it override. I want undo to be an abstract method as well in command. Cool. Now we've got almost everything we need. We just need to go to our command invoker, and we need to add the ability to undo. There's my command invoker right up there. And now we're going to say undo command. Like that. And then we're going to call undo on it. All right. Let's do another thing now. In our command invoker, when we do a command, let's keep a history of these. So I want to create a stack here. So I want to do a new stack of what's on the clipboard. Right here. New stack of commands. Oops, I meant to have this on the clipboard. Like that. And we're going to call this our undo stack. Okay? Got it?
Got it.
In fact, this is just going to actually be this. It's going to be undo. It's not going to take the command. I'm just going to call undo. And now, when we execute a command, we're going to say undo stack. Which of these are we going to call? Gut level. Don't think too hard. What?
Pop.
We'll call pop. Unfortunately, pop won't work. There's nothing on the stack. I know this is a totally unfair question. It's based on the slide I showed yesterday on the on stacks. What do we do to what show these methods do we call to put something on the stack?
Push.
That's what we do. So we're going to push the command on the stack.
Wait, but if we're undoing.
Yeah, we're not undoing. Look where I am. I'm in do command. You were right if we were down here. Now I want to do the undo stack dot pop. You were totally right. Yeah, I think that's what I thought. You were thinking that in this space. And we want to just pop whatever's off of there. Declare a local on it like that. We want to also check to see if, hey, is there anything here? If the count is if it's equal to 0, then get out. There's nothing we can do. Don't ask me. Don't ever call me here, Campbell, when I've got nothing in the undo stack. I'm going to get angry. All right. So now there's our command. Comes here. And then we just call command.undo. Sweet?
Yes.
Okay. I almost think this is going to work. We now just need to call undo at the right spot. That's all we need to do. Let's make sure in our text command change command, does our undo work? Yeah, we're just passing in the other value. See how simple this is?
Yeah.
Okay, now all we need to do is call it at the right time. So we need like kind of a Control Z kind of thing. We have a preview key down here anywhere. Window preview key down. I can throw it in here, just for simplicity and speed here. So I'm going to say if e.key is equal to key.z and control key down, like that. So we've just hit control Z. Then I'm going to, what call am I going to make here? Do you remember what class it was in that has the undo method we just added?
No.
Okay, I'll give you a choice.
Yes. Undo.
What class is it in? It's in one of these four. The client, the invoker, the receiver, or the command.
Command.
It is not in the command.
Client.
It is not in the client. We are in the client now. So we're running it down.
Then the invoker.
It's the invoker! He wins! You did it, Campbell! You did it! Do I have a button that works? Can I hit the photo button? Whoops, man. Invoker. Wait, why don't I see invoker in here? really like blown away as to why IntelliSense isn't helping me. What's going on? Why can't I see you? It's my class.
Public.
Huh, that was weird. IntelliSense was just like, yeah, I don't know if I'm gonna help you right now. And then we're gonna call undo. And I think that's it. We're running out of time, so it better work. We've got 4 minutes to fix any bugs. Okay, so here we go. Load the game. All right, I'm gonna put an 8 in here. Oh no, I'm sorry, I'm gonna put a 9 in here.
Nope.
Oh no, I'm gonna put a 7 in here. Oh, I'm gonna undo now. Undo, undo, undo. Nothing! What? Impossible! All right, put a breakpoint here, see if we get here at least. Oh, we do get here. Okay, now we get here. Undo stack, got something in here. Okay, cool, we got it. We got a command. We're saying 4, 2 should now be 7. We're calling undo, which gets us into our text change command called change text 247. That's all looks good.
I think it's just doing it so quickly.
No, but we should see it.
Yep.
The text is, there's the change. Oh, wait though, hold on. This, I think, that line of code just changed our undo stack, I think. I think that came in and got us in here. We need to set updating to true for a second is what I think we need to do. Let me just set my breakpoint. Let me just come in here and do this one more time. I got a breakpoint here. Let me hit undo again. Yeah, text changed is here. That's our problem. And then we're setting it right back. So you're right, it was happening so quickly. So let's hit undo again. Okay, so everything is cool except for here in set text. I think I want to make it so that the event doesn't fire, and I need to suppress events is what I suppress text change events. Is what I think I want to do. And I'm not sure, what I'm not sure about is I'm not sure if I want to mess with updating and all during this time or not. I think I want to create a separate field. Is what I want to do. And I want to say, hey, if changing text to undo. I think I'm going to do that. I'm going to make this a static boolean up here. Like that, make it public. And then what I want to do is go to my command invoker where I call undo, and I want to just, I want to do it here. No, I don't want to do it here. I want to do it for my text change command, and I want to do this. I want to say, I think it was in the Sudoku square. I think that's where I was. Set it equal to true. And then I want to set that to false. I want to do try finally, and then make sure I set that to false at the end. Oops, I meant SF. All right, that's what I want to try and do. Let's just try that now and see how that works. And we're out of time, so this better solve it. Load game, run, I'm going to put the breakpoints, run. Okay, 7, 8, 9, undo, put the breakpoint, should go to an 8, still no change. Come on. Why are you doing that to me? Sudoku square, do the text value change, hit undo. So what's coming in? So we're setting it, somehow we got set to empty. All right, let's change it to a 4. Okay, so we'll run, and now I'm gonna hit undo. And now what are we're in the text change event. And what's happening in here? So we're returning true, which means we've I'm being set to a 9. Why is it being set to a 9? Change text. Coming from here. Who's calling this? It's in the undo. The previous value was a 9. Then it goes to a 4. Wait, did it actually work? Is that true or not? No, I know I made it to a 4, then I set it to 9. Okay, wait, let's look at it again. All right, so here we go. So I hit undo. The first 9 is coming in. That's what I'm looking for it to go to. So we say, okay, cool. Let's change it. Then we get in here. That's okay. We're changing through undo. But now we get back. Yeah, I still want it to be a 9, so that's good. On value changed gets unstable list value. So the last value is now equal to a 9. Good. Now we're coming back into text changed again. This is now false. I think this might be coming a little later, because it's happening a little later. I think the problem is the event is happening not immediately when I call that. I think the problem. In other words, I think the problem is bigger. Now we're going back and saying, let's now go from a 9 back to a 4 again. I think that's what's happening. We're not calling this from anywhere else, right? It's only there. How can I fix this? I'm kind of stunned that this event is happening not immediately as we make the change. It's happening a little later. Well, I need to suppress the event just for a little bit. I could do this. I could do this, knowing that this works. This is not maybe a great solution, but I'm going to try this. I'm going to change this to just changed text through undo. Set it to true. I'm not going to finally turn it off. Okay, we're just going to wait until we get that event in there, and it should not be static. It's going to be static if we do it here. Let's just see if it works. I have a feeling that it's not going to work. It feels like there's two calls here to me. But what I'm going to do is set it to true, and if it's once, we're going to skip it just basically skips the next event here, is what it does. We can try that. I think we've got a problem because it's coming in twice. I hate this too, because this is one of those where right now I'm like, but if you just take a few moments and step away, all of a sudden you realize, oh, okay. You realize the solution, what it's going to be. So now I just hit the number 3. So I'm changing the text here to 3. Now I'm going to hit undo. Changing it to a 4. And then, I'm sorry, I looked here and saw the 4. Looks like it's coming in twice, is that right? I'm going to hit it again, undo again. Undo. Yeah, we're saying go put it back to a space, and then put it back to a 3. So what's the call stack show? Yeah, I think that it's like the text is being, the command is being called twice. Okay, I have an idea for not a great solution, but one that I think that can get this functional in like a minute or two. And that's what I'm going to go for. And then later we'll figure this out. So we'll just kind of give us a little bit of satisfaction to see the undo and redo working. What is it? I want to look up here. I'm going to change this to an int. If I need to skip to events here, num text changes to skip. Set that equal to 0. And here I'm going to say, hey, if this is greater than 0, then I'm going to say decrement it. Like that. So now what I can do is I can now set this to 2 right here. So I think I need to skip 2 on the undo. And this is not a great solution. I don't like it at all, but I think it's going to work. So let's try this. 3. So we're going in. Here's what changes becoming a 3. Now I'm going to hit undo, and we get nothing coming in. Nothing.
I think we're going to have to stop
All
the
right.
show.
Campbell says we got to stop the show. He's the boss. We're going to get a raid going here. Sorry, kids. Really wanted to have that working.
Dang it.
What's the dang it for, Campbell?
That it's not working.
Well, starting the raid. Kids, thanks so much. We'll see you in a week, and we'll probably know exactly what's going wrong in like about a minute. Take care, everybody. Thanks for joining us.
Okay.
And we'll send you over to Lionel X.
Goodbye.